Welcome to The Explainer. So today we're tackling something huge, the massive shift in how we actually create software. We're moving from a world where pretty much every single line of code was typed out by a human into a brand new era, one where we build things in partnership with AI.
This right here, this simple little equation, this is basically the core of the entire revolution. It's this idea that writing a really good instruction, a prompt, is the new way of programming. We are at a serious inflection point, where the very meaning of coding is changing right in front of us.
But to really get where we're going, we got to take a step back and look at where we came from. For decades, if you wanted to build software, it meant a person, a programmer, was painstakingly writing every single instruction, character by character. You know, it's kind of wild to think about now, but back in the 90s, you couldn't just Google an error message. If you needed to learn a new language, you often had to find someone who owned the physical textbook and literally photocopy the pages. It took years and years of intense practice and just pure memorization to get good at it. And if you look over the decades, you see this really clear pattern, right? We kept moving up these generations of programming languages, and each step added another layer of abstraction. We went from the raw ones and zeros of machine code all the way up to high-level languages like Java or Python that look a lot more like English. The whole point was to get closer and closer to how we actually think, but it still required some deep, specialized skills.
So the really big shift in this whole era was moving away from thinking like you're writing a step-by-step recipe to thinking more like you're building with digital Legos. That's object-oriented programming. You create these little objects that have their own data and their own behaviors, and you can snap them together. It made building huge, complex software way more manageable. Now, the first huge break from this classical way of doing things, it wasn't about writing smarter code. Nope, it was about letting the data do the writing for us. And that, my friends, was the dawn of what we call Software 2.0. Yeah, this term was coined by AI visionary Andrej Karpathy, and it was a total departure. Instead of a programmer writing out every single rule, a machine learning engineer just curates a giant pile of data. Then, an algorithm trains a neural network on that data, and the final trained model, that's the program. Think about it. For image recognition, you don't write a bunch of if-then rules to describe a cat. No way! You just feed a model millions of cat pictures, and it figures it out. The model becomes the program.
And this is the absolute core of that shift. The developer's job changed completely. They weren't an author of logic anymore. They became a data manager, a trainer, a curator. The quality of your program wasn't just about how smart your code was. It was about how good and how big your data set was.
Okay, so that brings us right up to the present day and what people are starting to call Software 3.0. This is where AI stops being just a tool we train and becomes an active partner, a co-developer, really, in the actual creative act of building software. And this new era brings 4 huge changes to the table. First, it democratizes everything, letting people who can't code build real software. Second, it just massively accelerates the whole process. Third, it raises the abstraction level again, so you worry less about syntax and more about just breaking down the problem. And finally, it creates code that can actually evolve and improve itself.
This table just lays it all out so perfectly. You can literally trace the evolution of the developer, from algorithm designer and software 1.0 to data curator and 2.0, and now to this new thing, the AI or agent orchestrator. And the tools have changed too, right? We've gone from compilers and IDEs to the large language models and agent frameworks that are the toolkits of today.
Okay, but of course, with all this incredible new power, it's not all rainbows and unicorns. There's a new set of rules, a new set of high-stakes trade-offs that the whole industry is just now trying to figure out.
So on the one hand, you have this promise of just massive efficiency. I mean, look at this. You've got huge companies like Cognizant aiming to generate half their code with AI within a year. The push for speed and cost savings is enormous.
But then, you had the other side of the coin. The risk is absolutely real. And this isn't some made-up scare story. This headline, it's real. It happened. You give an AI that's super powerful, but maybe not super mature, too much control, and things can go catastrophically wrong.
So this puts developers in a constant balancing act, right? You're always weighing these critical trade-offs.
Do you go for pure speed with a language like C++, even if it's less safe? Or do you pick something like Rust that gives you both, but it's a lot harder to learn? Do you want the fast and loose flexibility of Python, or the rigid structure of Java? These choices are central to modern software development.
And you can see this exact trade-off playing out in real time with the explosion of TypeScript. Look at this, over 40% of developers are using it now. Why? It's pretty simple, actually. It bolts a layer of safety and structure onto JavaScript, which is super flexible but can be, well, a bit wild. It's a direct response to this need for more safety. All right, so if that's where we are right now, what's next? What does the road ahead look like? Let's get a little speculative and look at the path to Software 4.0 and even beyond. Okay, the projections for the next 10 years are, honestly, they're kind of mind-bending. In the near term, it's all about getting good at managing these AI agents. Then, in the midterm, those agents might become autonomous meta companies that can just run themselves. And then, long-term, you could have Software 4.0, massive decentralized AIs managing things like our power grids.
And if you want to look even further down the road, things get straight up sci-fi. Experts are talking about 6th-generation languages that AIs use to write themselves, and even 7th-gen languages for coding directly with your brain. I know, it sounds like something out of a movie, but this is what serious people are thinking about for the long term.
Which of course brings us back to the biggest question of all. Look, the human programmer isn't going away, but the job is changing, profoundly. We're moving away from being the bricklayers, the ones writing every single line of code. Our new job is to be the architect, the guide, the ethicist, the one who sets the goals for these incredibly powerful systems. So the question really isn't, can you code anymore? The real question is, can you guide intelligence?